So every computer will have some special flags or some bits which are called as status bits or control bits. So these bits are used to find out the status or what has happened in the previous instruction, and based on that we'll take some decisions. So these will be very useful when we talk about the conditional branch kind of instructions. So let's try to understand these bits first, how to set those bits and how to clear those bits, and then we shall see how these flags will be applicable there. Okay, now try to understand this one. So let's assume that we have a 8-bit ALU, simplest ALU I'm talking about. It means that the input are going to be 8 bits, 2 operands of size 8 bits, and the output is also going to be 8 bits. Let us say one input is A and other input is B, and the result, let's call it as F. So what I mean to say is, if you have 8 bits, and now the result produce whatever the operation is. We don't care about the operation. Operation could be either addition or subtraction, multiplication, or even the operation could be logical operation like ANDing, ORing, whatever. Let's say the result is going to be like this: F0, F1, F2, F3, F4, F5, F6, F7, right? In case if it is represented as if it is interpreted as a 2's complement number, we know that this is the sign bit of the result. This is sign bit of A, sign bit of A, sign bit of B, and sign bit of the result. Okay, and then assume that the carry which comes from this stage and goes into this stage, the carry which comes from this stage and goes into this stage, let's call it as C7. C7 is nothing but the carry into the most significant bits, and the carry that comes out of this stage, let's call it as C8. C8 is nothing but the actual carry that comes out of this operation. This is especially when we are talking about the addition. So if we are talking about the addition, the carry that goes into this, let's represent it as C7, and the carry that comes out, let's represent it as C8. Okay, and now we can define 4 flags. The first flag, V, is called as overflow flag. So which means that this flag will be set to 1 whenever there is a overflow, and this flag will be set to 0 if there is no overflow. And where will it be useful? Whenever we are talking about 2's complement addition. So what is overflow? We have already seen this overflow in digital while discussing about 2's complement number system. You please refer to the examples there. Okay, so how to identify overflow is, one way of identifying the overflow is, okay, what is overflow? Whenever the result is a number which cannot sit in that given bits. So for example, if you are thinking of it as a 8-bit arithmetic, it means that we can represent numbers only using 8 bits. Using 8 bits, what is the minimum 2's complement number possible and what is the maximum 2's complement number possible is, the minimum number is minus 2 power 8 minus 1, and the maximum number is 2 power 8 minus 1 minus 1. So this is the minimum number and this is the maximum number. Now if you interpret it, if you convert it, it is going to be minus 2 power 7, which is minus 128, and it is 127. Therefore we can only store numbers ranging between minus 128 to 127 inside these 8 bits. We cannot store any number beyond that. Now if the result happens to be a larger number, let us say the result happened to be 130, then it doesn't fit there. Then the overflow flag V is going to be set to 1. Got it? And how to test it? So the logic which is used to test it is by seeing what is the carry coming in and carry coming out. Sometimes this is also represented as C in and C out. We have already seen it in digital, you please refer to those videos, right? So whenever I exclusive OR, if C in exclusive OR C out is equal to 1, which means if both are not equal, then it represents generally overflow. This is the simplest way we can find out whether there is overflow or not. That is why if you observe this one, this after performing the addition, let us assume that the operation that we are doing now is addition. After performing addition, you can take C7 and C8, and if you apply exclusive OR, then the result is going to be stored in V. Therefore, V indicates overflow flag. The simplest way of doing that. And the next flag is Z. So Z flag is also called as zero flag. So what does it indicate? It indicates whether the result is 0 or not. So this particular flag is very useful for comparing two numbers. So whenever two numbers are, let us say, subtracted, then if the result happens to be all zeros, then we can test here what has happened, right? I mean, if Z is 0, if Z equal to 0, then we can declare that the result is 0. Not just in comparison, even in testing instruction. Just now we have seen an instruction called as test, right? So what does test do? It is going to find out what a particular bit is going to be. Let us say we have 8 bits like this: 0, 1, 1, 0 and a bit X and 1, 1, 1. Let us say we have 8 bits like this, and we don't know what this bit is, or we want to write a program which wants to find out whether this bit X is 0 or 1. So what are the various ways possible? One way is you can just shift it and get to location here and then verify the sign bit, or you can use the rotation and you try to get it into carry, and again you check what the carry is. Or the other way of doing it is by using the zero flag. How can I use it is, in order to test only this particular bit, you try to mask out all the bits, which means by using this I'll apply AND. So one of the operand is going to be this, and the other operand I'll do this, because the position that I wanted to test is, let us say, 5th position from MSP, 1, 2, 3, 4, 5. This position I wanted to test. Then I'll take the actual data, and then using this pattern I'll just apply ANDing. Then the result is going to be 0, 0, 0, 0, X 0, 0, 0, right? And now if X happens to be 0, if X, the original X, if it is 0, then what happens is the entire pattern is going to be 0 and the 0 flag is going to be set. Therefore, 0 flag can be used to decide whether this bit is 0 or 1. In case if this bit happens to be 1, then what happens is the result is not 0. Therefore, 0 flag will not be set, which means if Z equal to 1, it means that this bit is 0. If Z equal to 0, this means that this bit is 1. Therefore, you can even use this 0 flag not just to test the entire result. You can also test one simple bit. For this, the instruction given is test instruction. So when you apply test instruction, what happens is it will just automatically AND it with this and then see what the Z value is. Got it? So it is not the only way where using which you can test a bit. You can use it, you can even do it using other methods like rotation. So let's see it next. And the next one is sign bit. So why sign bit is used is in order to find out the sign of the result. So we know that if it is a 2's complement number, the most significant bit is going to be this sign bit, right? So see this, it is by taking the most significant bit F7 that is passed into sign. Therefore, if F7 equal to 1, it is negative number, S will be set to 1. If F7 equal to 0, it is positive number and it will be set to 0. Why will it be useful is, there will be certain kind of branches which will be like branch if positive, branch if negative. So what does it mean is, whenever you perform any operation, you just see what the sign of it, and the next operation, if it is branch if negative, then if the result of the previous instruction led to a negative number, then we are going to take a branch. If the result of the previous instruction is a positive number, we will not take a branch. Got it? So all the time what happens is, we perform some arithmetic and logic operation, and after that operation we'll invoke the branch. Now that particular branch statement, if it is conditional branch, will check these flags. They will not go into the result and compare it. Only by using these flags they are going to take the decision. Got it? So these flags are going to be automatically set for every arithmetic and logic unit, but then whether they are used or not, that depends on what is the type of the instruction next. If it is a conditional branch instruction, they are going to use it, and then based on what are the contents of this, they will take some decision. Got it? So F7 is used to set S. And the next one is C. C means carry bit. Okay, so why is carry used is, in order to find out whether the previous arithmetic addition has led to some carry bit or not. In case if there is any carry, that is indicated by C8, right, which is nothing but the carry out. Therefore C8 is directly passed into C. Got it? So we can use C bit whether to find out there is a carry which is generated or not. Also we can also use carry for doing various other things. I'll just show you one small example. Okay, we can even test this one. If you want to see what this bit X is, if you want to find out whether it is 0 or 1, one simplest way is, you rotate it right 4 times. First time this will go into carry, second time this will go into carry, third time this will go into carry, and after this 4th time rotation you can check what the carry bit is. Therefore carry bit can also be used to test any bit of the data, not just the carry, but anyway when it is applied with addition. So if the previous operation is addition, then carry bit will generally say whether there is a carry or not. That is why it is named like that. But apart from this, it can even be used like this, right? And the other way where we can use it is whenever we are performing comparison. So how do you compare? If A and B are compared, then subtraction will be done. A minus B will be done, right? Now there are two cases. One case is when A and B are signed numbers, right? And other case is when A and B are unsigned numbers, right? So what happens is, if A and B are signed or unsigned, if in this case of signed, if A equal to B, then what happens is Z will be equal to 0. By using this condition we can test, or we can declare that A is equal to B. Even in unsigned number also, if A is equal to B, then output will be 0, the result will be 0. Then we can say that it is both are equal. Otherwise, if A is greater than B and if it is a signed number, we know that the result is going to be positive. So the result is going to be positive means the sign bit is going to be positive, and the 0 bit is going to be 1, 0 flag is going to be 1, and 0 is going to be 0. So if you see this, in case of sign, what does it mean? I performed A minus B and then I got this sign as 0, which means I got a positive result, and the value of 0 flag is 0, which means both are not equal, and the result is positive. Also you can include one more flag here, right, the overflow flag. If the overflow flag V, let us say, is 0, which means there is no overflow, and the result is 0, then we can say that A is greater than B, right? So if this one fails, we can say that A is less than B. Now in the unsigned number, if in order to know whether A is greater than B or not, then what should happen is we'll test the carry. If carry is equal to 1, okay, then we can declare that, and Z equal to 0, then we can declare that A is greater than B. I'll show you with examples what does it mean. Okay, so now we shall see examples about how to compare and how to use these flags to come to some conclusion. So what is it I'm trying to say here? These flags are not just going to be useful to do one task. They can be used in order to perform various other functions depending on how you want them. So one important application is how to find out how to compare two numbers. Generally we compare two numbers by performing this subtraction, and after subtraction, instead of looking at the result, we can look at the flags, and then we can know which condition it is. Depending on what condition it is, we can apply some other branch statements, right? So we know what the branch statements will be like: branch if equal, so that will be hit whenever A equal to B, or branch if not equal, or branch if A is greater than B, or branch if it is less than. So for all such conditions we have to compare. So for comparison these flags will be useful. Now I'll take some examples and I'll show you. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.